The purpose of the activity for Newton's second law with constant mass is to give us more experience dealing with Newton's second law, which says that the force on an object, the net force on an object equals the mass of the object times the the object's acceleration. This is the basic setup the big picture setup of how we're going to do this lab. There are two masses involved in this setup. The cart with the masses on top we'll call M1, and we'll also have a hanging mass down here that we will call M2. We are going to ignore all the friction involved in the pulley, and we're going to ignore any friction in the cart. We're going to keep things simplified. So the only force involved in this lab will be the force of gravity pulling on the mass M2. Here's a close-up view of M1. It will consist of the cart, which is supposed to be 500 grams, two of the 500-gram rectangular bar weights that we use with the cart, so that brings the total to 1,500, and then we'll have a total of 1,050, which will make it 2,550 grams of weight for M2 to start with. Here's a close-up of how we've got it set up. The reason we have it in little pieces like this is we're going to take weights from this cart and put it on the hanging weight, which is why we say that the total mass will be constant. Here's a quick review of how this will be set up for you, but it may not be plugged in, but you plug in your LabQuest on the bottom part of the gate, and I'll show you in another part of the video how to remind you how to set up your LabQuest and how we're going to gather the data. So returning to our big picture, we see our LabQuest is set up here with the photogate and the pulley, and I'll show you in a minute review how to set that up. But we have M1 and M2. The total mass will not change because what we'll do, this will be the initial weight. We'll have 50 grams here, and this is in your lab notebook, and 2,550. So the total mass between M1 and M2 will be 2,600 grams or 2.6 kilograms. Then we will release the cart. We'll use our LabQuest. I'll show you in a minute. We'll use the LabQuest to find the acceleration of the cart. Then we'll remove 50 grams from M2 and put it onto M1. Then we'll run the lab again, and we'll do that for a total of 8 trials. To review how we set up our pulley to measure velocity, it has to go in one of the side digital slots, and if you want to guarantee it works, it should be turned off when you plug it in and then turn it off, otherwise you may have some problems. My mode is photogate timing. Click on motion. I need to make sure I'm on the pulley. When you first turn your LabQuest on, it's liable to be in the vernier picket fence, so you have to pick the pulley and in groove and just leave it as stopping in data collection with the stop button and hit OK, and then it's set up to use for the lab. Once we have our graphs, we need to find out what the measured acceleration is. So the first thing we want to do is go to graph, and let's just show one graph, show graph 2, so we just have the velocity. Now we learned in Unit 1 that the slope of the velocity graph gives us the acceleration, so that's what we're going to use to find this. So I want to go back to graph though. I'm going to look at graph options because this picture was too straight up and down, so I'm going to go to my right and I'm going to change that to like 1. And you can play around with this and see what works. But that spreads it out. It makes it a lot easier to highlight that way. Then I'm going to highlight my graph, the part that's straight. I do not have to get all the way to the peak, just so I have the part of the graph that's straight. The slope of that line should give me the acceleration. Then I go to Analyze. I go to Curve Fit. I'm going to do the velocity, and I'm going to choose a linear model. And right here my slope is 1.75, so my acceleration would be 1.8 in this example. This is what I want Newton's second law with constant mass to look like in your lab notebook. I do want this diagram in your lab notebook. As always, you can find the picture on the web page if you need more time. And I want this calculation in your lab notebook. Hopefully you can understand what's going on, but as a minimum I want it written down that your net force, Newton's second law says my net force equals mass times my acceleration. In this case, the only force acting, we're ignoring resistance, we're ignoring friction in the pulley and on the cart. So the only force acting is the force of gravity, which is the mass 2, the mass that's hanging, times gravity, times the acceleration of gravity. So that is equal to my mass. Now we're looking at the whole system. So it's not just M1, it's not just M2. We're saying we have one force, this is tied with a string, so we have one force acting on this whole system. So we have to deal with that entire mass times acceleration. So when you divide by the total mass, you get your acceleration should be equal to the hanging mass times the force of gravity divided by the total mass. And we're going to see how accurate that is. The data we're going to use, and one reason I'm trying to keep the numbers small is so that the cart doesn't go too fast. So we're going to have 2.55, and which you've already seen how we're going to do that earlier in this video. So we have, here's the data we're going to use. Our M2 goes up by 50 grams or 0.05 kilograms every time. So my total mass is supposed to be 2.6 kilograms each time. So if in my first row calculations, in theory, if I plug that data in, I'm going to use 9.8. I'm not going to make you weigh all these different masses. We're just going to live with the error in those. But let's go ahead and use 9.8 to be as accurate as we can. So I multiply by 0.05, divide by 2.6, and I got 0.082 should be my acceleration. In my made-up data, I measured it as you've seen earlier in the video. I took the slope of my velocity graph, and I've got 0.079. Then I found the percentage difference, the same way we always do that, by subtracting the two accelerations and dividing by my theory acceleration, and I got 3.7%. The force of gravity is equal to the mass that's hanging times 9.8, and that's 0.49. And then what you will do is you will have all the forces of gravity, you'll have the lab accelerations, and we will enter that into our calculators and generate a formula, Fg equals k times the acceleration of the lab. This obviously should turn out to be the total mass. We'll see how close we actually come. Good luck.